7.3 is one of my favorite lessons all year because it deals with a word that has put fear into your parents and generations before you. It's called trigonometry. This is the basis for all things triangle. Trigonometry is basically a relationship between two sides of a right triangle based off of an angle. As a matter of fact, your parents way back in the when, they learned trigonometry like this. They learned trigonometric ratios based off of an angle, based off of sine, cosine, and tangent. They had to do things with a table. Your generation, though, doesn't have to do it this way, even though you could if you wanted to. Your generation is going to use the calculator to learn most of everything. Because they're scientific calculators, they have all that information pre-stored into it, and not just 4 places, but a lot of places. So the first thing I want to talk about are calculators. Calculators are required, but they have to be in degrees. I know this calculator is in degrees because right up here there's a little D there, or a DEG. It is in degree mode. I can easily check to see if it's in degree mode by pressing sine of 30 degrees. And if you punch in sine of 30 degrees, you should get 1/2 or 0.5. Now the thing is that if you're not in degrees, the calculators that I am really accustomed to are Casios. That's what I have in class. The way you would change it is you have to press setup, shift setup. It's right next to your mode button. And there are 4 choices. Well, there's a bunch of choices. Degrees, radians, or gradients. We need to be in degree mode, which is number 3 on this calculator. It may be slightly different on the gray calculator. Let me check here. Shift setup. Degree is number 3 on the 115s as well, just so you know. If you have a different model calculator and you're not sure how to switch it between degrees, radians, and gradients, you need to ask, and I will show that to you individually because there's a lot of different calculators out there. But just by a show of hands, if you punched in sine of 30 degrees and you got 0.5 or 1/2, please raise your hand so I know how many are on the same page as me. That's the majority of you. Almost everybody, or at least everybody who has their head off of their desk. Awesome. Okay. Second thing. Now that we've talked about calculators, basically trigonometry is going to be based off of 2 sides of a right triangle. And sine, cosine, and tangent are going to compare 2 of the sides. It's going to be based off of an angle. And so what we're going to do is we're going to figure out which side is the opposite, which side is the hypotenuse, which side is the adjacent. And we're going to choose between sine, cosine, and tangent based off of this acronym called Sohcahtoa. Sohcahtoa is an acronym that is going to tell you which one to use. Are you going to use sine, which is the opposite over hypotenuse? Are you going to use cosine, which is the adjacent over hypotenuse? Or are you going to use tangent, which is the opposite over adjacent? Sine, so, stands for O over H. So. Cosine stands for Ka, cosine, A over H, Ka. And Toa stands for the tangent, which is O over A, Toa. It's a way for you to remember which 2 sides we're talking about. So for every problem that you get, it doesn't matter what the triangle is. For example, if I give you this angle right here, and I say that it is 21 degrees. That is your angle that you're given. What is opposite will be this side. This side will be your O. Which side is your hypotenuse? The hypotenuse is across from the 90. That's your H. And which side is your adjacent is the third side? Every single time you get a triangle, you have to highlight whichever angle you're talking about, and you label O, H, and A. Or as I like to remember it as, oh ha, ha, like that, just like that. It's really easy to remember it that way. If I can remember this is the angle, that's opposite the angle. That's the hypotenuse of the angle. This is the adjacent one, touching the angle but not the hypotenuse. Then what you can do is you can figure out anything you want based off of which sides we use. For example, if I have 5 and a 6, just like this, okay? Then the opposite over adjacent would be tangent. The tangent of this angle is equal to the opposite over the adjacent. That's how it's going to work. But if I had, let me change these numbers real quick just so that I have it here. I don't know what this is. 3, 4, 5. If we're talking about the O and the H, we're going to be talking about the sine, opposite over hypotenuse. If I talk about the A over H, we're talking about the cosine. Question? It does. It does matter between the order. Now, I chose that this was O and this was A because this was the angle I was using. But if, by chance, we start to use this angle over here, let's say this angle was 31 degrees, then it is possible for me to have the O, the opposite, over here. And the adjacent could be over here. It depends which of the acute angles we are talking about or which angle we are using. So the first thing that we do, we always label it OHA. O for opposite, H for hypotenuse, A for adjacent. And then we're going to make a choice. The choice is, do we use sine, cosine, or tangent? And it's going to be based off of which two sides were we given? O and H, A and H, or O and A? Sine, cosine, or tangent. And we're just going to say Sohcahtoa to remember that. So as a matter of fact, this is what I want you to do. You are going to help me by remembering Sohcahtoa by saying it out loud. With me, as I go across, you're going to say Sohcahtoa. Ready? Go. Sohcahtoa. We're going to do that 2 more times. Sohcahtoa. 1 more time. Sohcahtoa. The whole idea is you remember when you say ka, you have to have the ah in it, the A over H. And when you say so, you got to have that H in it. So. And then when you say toa, we have to have that O and the A. That way you know which one goes with which. Otherwise, we're not going to set up these things correctly. And the things that we're going to be doing, there's always a trig function, there's always an angle, and then there's a ratio, a top and a bottom. There's 4 parts. We got to know 2 known values and 1 unknown value and reduce everything when we do it. So with that being said, I'm going to skip this little star point. We're going to jump right into an example. You have a worksheet in front of you. This is the very first problem on the worksheet. The very first problem on the worksheet says, what's the tangent of A? And you're not going to know how to do it unless you know OHA and you know Sohcahtoa. So the very first thing I do is I look at which angle did they tell me to find, angle A. Then I go to angle A and I highlight the angle by putting a little arc there. We're talking about this angle. That's what step number 1 says, highlight the angle. I highlighted the angle. Now I need to label which one is the opposite, which one is the hypotenuse, which one is the adjacent. Oh-ha! That's what we're going to do right now. Which number is opposite? If you said 16, you're right. Which number is the hypotenuse? You said 20. You are correct. I put those letters inside the triangle very much like I did for the 45, 45, 90 and the 30, 60, 90 degree triangle. There's one other side. Oh, I need an A. That's the 12. A is always the last one that we do. Now, here's how trigonometry works. It's the easiest lesson all year if you paid attention so far. Tangent of A. We have that angle A. The tangent of A is equal to, what's the acronym I'm supposed to remember? TOA is the part that I want to know. TOA means I want the O over the A. What is the O? What number?
16.
What is the A?
12.
Find the value of each trigonometric ratio in reduced fraction form. It's 16 over 12, but we have to reduce it. Put this in lowest terms. Let's divide by 4, or plug it into your calculator and let the calculator reduce it. You can do that as well. If you punch this into your calculator, use the fraction button, 16 down, 12, press equals, and it will reduce it for you. It should do something like 4 over 3. Is that what you got?
Yes.
Guess what? That's all the work that there is. It is easy if you paid attention and you learned Oha and Sohcahtoa. How is this going to change? They're going to change. Sometimes it's going to be sine, sometimes it's going to be cosine. Instead of sometimes of A, they might use angle C instead. Shall we do another one? Let's do another one. I jumped to number 4 because number 4 is different. Number 4 says, find the value of each trig ratio in decimal form. This time they want it as a decimal, not as a fraction. And we need to round it to the nearest tenth. So we're going to do that. First thing I do is I go, what angle are we talking about? We're talking about angle A. That's given to you in the problem. Cosine of angle A. So I go to angle A and I highlight it. And then I have to follow what step number 1 says. It says label O, ha, ha, ha. O, H, and A. Which one is opposite? Which number is opposite? Tell the person you're sitting next to. If you said 27 was the opposite, good job for you. H stands for the hypotenuse. Which number is the hypotenuse? And then the last number is your adjacent. And now that you've labeled that, you go back to the problem and they asked you to find the cosine of angle A. So I write out cosine of angle A. Don't forget the letter angle A because that's what we're dealing with. We're dealing with this angle. And I have to go back to that acronym, Sohcahtoa. Which one am I, what part am I going to use of Sohcahtoa? Ka. That is the A over H. If you remember Ka, then you now know which number over which number. Which number over which number? It is not hard. I told you it would be the easiest, hardest lesson all year. It's only hard for people who weren't paying attention to what you're supposed to do. Now, this is what it would be as a fraction, but we need to turn that into a decimal. How do I do that? We punch in 36 over 45. And it puts it in lowest terms as a fraction. But I want to put it as a decimal, so your decimal button is this SD button right above the DEL key. That's standard to a decimal. As a decimal, this is 0.8. The cosine of A. As a fraction would have been 4/5, but as a decimal it is 0.8. That's the nearest tenth as well, by the way. What I love about it is I go, man, that's easy. Bet you guys could do that, huh? Now, how does it get harder? It gets harder when they don't tell you which one to use, like number 7. So let's jump to number 7. And it says, find the missing side. They give you an angle, they give you a side, and they give you a missing side. You know 2 things. You have to find the third. So everything is exactly the same as what we did before, except they didn't tell you which one to use. So here's the deal. They gave you 50 degrees. Highlight it just like you did before. We're going to use the 50. Label it O, H, and A. What's O? What's opposite this side? Over here. That's O. Which one's H? Across from the hypotenuse. 16 is the H. And then guess what? The A is over here, but there's nothing next to it. You're not going to use it. Why don't you use the A? Because there's no number, there's no letter next to it. What does that mean? That means that we need to use the function that deals with the O and the H. We're going to have to choose. Do I use so? Do I use ka? Do I use toa? And you guys think we use which one? So. We're using the O and the H. So here's what we write. We're choosing so I'm going to use the sine of which angle? Is there a letter there? No, there's a number. Use the number because we're going to need that. We need the number. We need the angle. The sine of the angle is equal to the opposite over the hypotenuse. The opposite is what? X. The hypotenuse is 16. So here's what we have. We have the sine of 50 degrees equals x over 16. And since it's x divided by 16, we need to find x. We need to get x by itself. The opposite of divided by 16 is times by 16. We're going to times by 16 on both sides. 16 times the sine of 50 degrees. 16 goes into 16 one time, and you're left with x. This is what our answer is going to be, except we're going to use our calculator to figure that out. Remember how we had it in degree mode? This is where we type in 16 times the sine of 50 degrees equals, and it's going to give us a decimal, rounding to the nearest tenth. The tenth place is this place right here, and I have to look if this is 5 or higher, this rounds up. If it's 4 or less, this stays the same. 12 point, what do I write? 12.3. And I'm going to put a little wavy line. You might as well get used to this because you're going to see me do it a lot. X is about equal to 12.3. X is approximately 12.3. Means I'm rounding. And this is trig. What we're doing is saying that for every 50-degree angle right triangle, there's going to be a certain ratio with it. This is how architects figure out what angles the roof is going to be at. Especially for water to run off of it. It has to be at a certain angle. This is how architects plan on buildings or cabins that are in the snow so that it can be at a steeper pitch so that the snow falls off of it and doesn't build up on top of the cabin and cave in the cabin. If you go to the higher elevations, that's what those look like. Now let's try another one. I'm going to go a little faster this time. There's my angle. Opposite is over here, but nothing's next to the opposite. I'm probably not going to use it. Hypotenuse is next to the 17. Adjacent is next to the x. I have an angle, and I already know which function I'm going to use because I see what things I'm going to use and what I'm not going to use. Which trig function do you use? If you said ca or cosine, you are correct. Don't forget it's cosine of an angle equals a over h. What is your a and what is your h?
X over 7.
There's your equation. You want to find x? So we're going to multiply both sides by 17. What we'll punch into our calculator is 17 times the cosine of 69 degrees. Let me punch that in. 17 cosine of 69 degrees. And it is approximately, rounding to the nearest tenth, 6.0922 is what I'm getting. I round that up. How many of you got 6.1? You should be practicing on your calculator too, by the way. Good. Really good. There's only one stipulation to this. And this is where the star is on your notes. In your notes, I have a little star. It says this. If variables are not in the numerator, then take the reciprocals of both sides to solve. Example number 9. That's the only way it gets harder, and I'll show you number 9 right here. This will be our last example. If you do this, and you have an O, and you have an A, and you don't use the H, sometimes what happens when you set this up and you have an O and an A, which one are we going to use this time? Toa. The tangent of which angle? 54 degrees is equal to, which one's the O? And the A is x. The variable is in the denominator for number 9. When you have a variable in the denominator, this is where it gets, where I see students make the mistake. They think you'd still divide by 14. You don't. We need x in the numerator. The easiest way to do this is we're going to take the reciprocal of both sides. There is this over an invisible 1. This is going to be x over 14. Flip this one and flip this one. The invisible 1 needs to pop out. And the last step, after you take these reciprocals, instead of dividing by 14, we times by 14, we times by 14, and 14 goes in the top. So if the variable's in the bottom, reciprocal, reciprocal, then you can multiply by 14, and in your calculator, you're going to have to type it in as 14 divided by tangent of 54 degrees. Or use the fraction button. I'm going to type it in as fraction button divided by tangent of 54 degrees. X is about 10.17 rounds to 10.2. I'm going to stop your notes right there.